So now when we evaluate trig functions, we have two methods that we can use. The first one's really simple. We can actually just use our calculator. But the important thing to note is that usually our calculator is working in degrees mode. And if we want to use radians, we have to enter radians mode to do it. Now, how do you tell which mode you're in? Let's have a close look at our calculator. What you'll see is that for most of the time, you have a little D up the top here. I know that's hard to see, but have a look on yours. That means that mostly you're in degrees mode. Now to enter radians mode, you need to press Shift and then the mode button, and then you'll be asked which of these you like, and you can see that 4 says rad, and that stands for radians, so you press 4. After that, your calculator will automatically be in radians mode. So if I want to find the cosine of 2, cos of 2, remember, if you're thinking about what 2 is, we know that 1 radian is a little less than 60 degrees. So 2 radians is going to be, I don't know, around about 115, 16, something like that. We don't need to know exactly though. All we need to know now is check that we're in radians mode, and you should now see that that little letter up there is an R. We should now be able to write cos 2, close our brackets, hit equals, and we'll get ourselves an answer. So the cos of 2 is negative 0.416, etc., and we'd have to answer that to a set number of decimal places, whatever's been asked. Why is it negative? Well, obviously this angle, which is around about 115-ish or so, is in the second quadrant, and cos is negative there. So this was dead easy to do. We've just got to be really, really careful that we're definitely using radians mode if we've been asked a question in radians. Now, how do you tell if it's radians or not? Well, if this was degrees, there would be a little degrees symbol there. If there is no degrees symbol, it must be in radians. Now, method 2, for special angles, it's best if we actually convert the angle that we're given in radians back to degrees, and that way we can use our knowledge of exact values. So think about what the special angles are. You should recall all of these ones, 30, 45 and 60, and we need to know sine, cos and tan. If you haven't committed this table to memory yet, it's not a bad idea to do so. Your reference sheet for your exam shows little triangles with a 60 degree and a 30 degree angle, and it shows a 45 as well. Okay, and it shows you the side lengths on those so that you could work these out. But if they're quick to hand because you've memorised them, it just puts you ahead. It saves time. So you should remember we have half, 1 on root 2, root 3 on 2. And if you can memorise those, you know that these ones for cosine go back the other way, half, 1 on root 2, root 3 on 2, so they're the exact same 3 numbers. Then for tan, I remember 1 on root 3 for the first one, and then I remember that you need to split that up into the 1 and the root 3. And those are the special angles that I know. Okay, so if we're asked a question like tan of pi on 6, notice there's no degrees symbol here, so it must be an angle in radians. I'm going to say that's the same as the tan of 30. How do I know that it's 30? Well, if you need to, you could be making your conversion over on the side, or as part of your working, you could say take pi on 6. If we wanted as degrees, we multiply by 180 over pi. The pi's cancel and we get 180 divided by 6, which is 30. But I can also just think this through in my head, and I can say well, pi is 180. So if I divide that by 6, I'll get 30. They're nice round numbers, easy to work with. And I should know that the tan of 30 is 1 over root 3. And this is helpful because if you put this into your calculator using method 1, you won't get the answer out as an exact value. It'll come out as a decimal. And if the question has asked for exact values, you won't get the marks. Now, a trickier example, sec of 5 pi on 4. The pi gives away that it's in radians, but also there's no degrees sign, so I know I'm working with radians here. Now, 5 pi on 4, think to yourself that's 1 1/4 pi. So quarter of a pi, divide 180 by 4, you get 45. And we've got 1 pi, 180, plus 45. So this is the same as sec of 225 degrees. Now, I thought that through in my head, but I'm very familiar with these. If you need to, you would start by actually saying 5 pi on 4 multiplied by 180 over pi, and then some very quick working, cancel these out, and we have 5 lots of 180 divided by 4, chuck it in your calculator and you'll get your 225. Okay, once you're here, you should know that sec is equal to 1 over cos of 225. And although you might be a little bit rusty on this, you should know that 225 degrees is over here in the third quadrant, and it's exactly, well, it's very much related to 45 degrees, isn't it? So if we know what cos of 45 is, we just have to think through what the sine is over here. So we have all stations to central. We know that in the third quadrant cos is negative. So it's just like 1 over cos 45, except it's negative. All right, now what's cos of 45? Well, that's one of our exact values. It's negative 1 over root 2. So if I have 1 divided by 1 over root 2, that's the same as negative 1 divided by 1 over root 2. We need to times and flip, and we get negative root 2.